Hello friends, we'll be discussing the concept of properties of indifference curve now. So we have already learned a lot about indifference curve. Now we'll be discussing what are the definite properties of this specific curve that we have in our question, or rather that we have in a syllabus. Let's start with the theoretical part of it. Now the following are the main characteristics of the properties of indifference curve. What are the main characteristics? The first would be indifference curves slope downwards from left to right. That means it goes like this. So this is the left, this is the right side. It slopes downwards. How exactly this happens? This is not even a curve that we're talking about. It goes like this basically. So it goes like, when we're talking about the curve, it goes like this. So this is the curve. It goes from left to right. This is the indifference curve. By definition, indifference curve is a curve on which all combination of two goods yield same level of satisfaction. This property implies that if a consumer wants to have more quantity of goods, one has to give up some quantity of another good in order to maintain the level of satisfaction. एक चाहिए तो एक हाथ से ले, एक हाथ से दे. That is the concept that you have to apply. So if at all you want to set up equilibrium in terms of the total utility, and when you're dealing with combination of goods, you have to give up something to gain something else. So if you want product A, then you have to give out something of product B. If you want more of product B, then you have to give out product A on the majority part. This is how the equilibrium has to be set here. Now when it comes to indifferent curves, the second part, indifferent curves are always convex to the origin. They're always convex to the origin. Now what convex and concave means? Let's talk about, let me just put on an example here. If this is the graph, this is the origin, correct? This will be the origin of it. Now convex is always like this. So this is like called the convex part. I'm sure everyone would have learned about how convex and concave lenses work. So if it is convex, the way we discussed right now, it would be like that. If it is concave, it would be like this, something like this. So this is concave now, and this is convex. So this is what you need to understand. You need to always figure out that indifferent curve is always convex to the origin. That means the curve is facing towards the origin side and not the back of the curve. So it implies that the indifferent curve is simply, or rather it implies that the indifferent curve is relatively flatter in its right hand portion and relatively steeper on its left hand portion. So if this is the curve that you're drawing, it is relatively steeper like this and it is relatively flatter like this. So from left side it is really steeper, on the right hand side it is really flatter. This is what the properties related to this one. Let us study few more properties. Let me just rough this off. And basically when we're talking about these things, you need to understand one thing, that this is very practical in approach. So when we're talking about only a convex indifference curve, following, or rather indifferent curves follow the principle of diminishing marginal rate of substitution. Hence it goes, or rather it follows the diminishing marginal rate of substitution here, which we have discussed earlier. Now it implies that as more and more of commodity is substituted for another, the consumer is willing to give up less and less of the commodity being substituted. As more and more of the commodity is being substituted for another, the consumer is giving or willing to give less and less of the commodity being substituted. What does it mean? If I'm trying to give up more and more of A, what is A being substituted with? B. So basically I'm giving less and less of B as a substitution here. Why? Is because I'm willing to give up A, but I'm not willing to give up B. So I'm keeping more of B and less of A just to set the equilibrium of total utility here. That is my requirement, that is my combination here. Now this is called diminishing marginal rate of substitution. This happened, or rather whatever things we discussed right now is basically known as diminishing marginal rate of substitution. If indifference curve be of any other shape, such as concave to the origin or straight line, then it does not follow the property of marginal rate or diminishing marginal rate of substitution. If it wasn't convex, if it was concave like the way we discussed, it wouldn't have followed the principle of diminishing marginal rate of substitution here. Straight line indifference curve shows perfect substitution between two goods. This straight line indifference curve, it gives out perfect substitution, or rather it gives out the perfect example of substitution between two goods. Thus, straight line indifferent curves implies that MRS, or marginal rate of substitution of x and y combination, remains constant as more unit of x are acquired in place of y, because the equilibrium is set according to that. Figure out the indifference curve that we have here. Case of perfect substitutes. This is indifference curve 1, indifference curve 2, indifference curve 3. Maybe at this point, if you take this point here, this is good y and this is good x. So if we take this point here, then it is more of x and little less of y. If we take the similar point on this curve, it is again more of x and similar quantity of y. So substitutes are happening here for y, and those substitutes are being replaced by what? That is x. That is an indifference curve. Now, when indifference curve is concave to the origin, now if it was the earlier thing that we discussed here was convex, now if it is concave to the origin, what happens basically? It implies that the marginal rate of substitution for x, or rather substitution of x for y, increases as the consumer obtains more of x in place of y, just like we discussed right now. Thus, it does not hold the assumption of diminishing marginal rate of substitution, which is the basis premise of the utility analysis. Hence, whatever thing that we discussed right now that it will hold true won't happen at all. Now, following figure presents the case of concave indifference curve. Now, the picture that we'll be looking right now will give you the basic description of how concave indifference curve looks like. Let's figure out. As I discussed, this is how it looks. So concave is like this, convex is like this. That's the original difference. That's the only thing that you need to look after. And convex doesn't follow, or rather concave doesn't follow diminishing marginal rate. However, convex follows the diminishing marginal rate of substitution. So this is the concave indifference curve, that is good x and good y. It has been mentioned this is a combination of A, where x and y commodity has been mentioned. This is the combination of B, where x and y. Now, or probably B and C, this is D, this is E, and this is the combination. So if you can see all these combinations, x is getting lower as it goes on the topper side. Let us figure out the explanation to this. A higher level of indifference curve represents a higher level of satisfaction than the lower level of indifference curve. Now, if you have to go higher level of indifference curve, that is this part, will give you more satisfaction because there is more of y and less of x. However, the lower level of satisfaction will give you less, or rather lower level of indifference curve will give you less satisfaction. Why this happens is because if you can see, the quantity of y is only this much and quantity of x is only this much, so it is like only this much. Now here none of the product, none of the good, neither x nor y, is considered to be on the higher side. Hence, higher level of indifferent curve, that means one of the product will be on the higher side as it is being, or rather the other product was replaced and the first product which is on the higher side was considered further. Now, the next part will be, this is because the combination lying on the higher difference curve contains more of either one of the product and more goods are preferred to less, as we discussed right now. Whatever on the higher side that we are discussing, or whether the IC curve, indifference curve, is on the higher side, one of the product will be on the higher side. That means that quantity will be on the higher margin as compared to the other quantity of goods that we have. Now, next part, indifference curve can never intersect each other. Very true. Indifference curve can never intersect each other. That will be like a complete delusion of the law itself. No two indifference curve will intersect each other, although it is not necessary that they are parallel to each other. If it doesn't intersect, not necessary that they are parallel to each other, there might be some other kind of lines as well. In the case of intersection, the relationship becomes logically absurd. Why? Is because in difference, there is no difference, hence they are different. But if they intersect, that means they are somewhere related or somewhere can be related there. Hence, it would show that the higher and lower level of equal, which is not possible. It would show that higher level of indifference curve and lower level of indifference curve are actually similar, which is not possible when it comes to indifference curve here. Now, for example, in figure 3.5, IC1 represents lower level of difference curve. If you remember the one that we discussed right now, and IC2 represents higher indifference curve. Let us see if we have that thing here. So let's go back on the figure here. In this part, this thing IC A 1 2 3 4 5, or rather A B C D E, that is the thing that you can take into consideration. Now this is what we have discussed. By assumptions, all the combination on the higher indifference curve contain high quantity of both goods. If there is higher quantity or higher indifference curve, it contains high quantity of both the goods. That is as per the assumptions here. Accordingly, higher indifference curve yields higher level of satisfaction as compared to lower indifference curve. So the lower the indifference curve, the lower is the satisfaction. The higher the indifference curve, the higher is the satisfaction. Just make sure this concept is very much fitted into your brain right now. Further, all the combinations on the same indifferent curve leave same level of satisfaction. That is again an assumption that we have discussed when we discussed the part of indifference curve itself. Now, in the figure below, two indifferent curves are shown cutting each other at point A. Let us go into the figure. So this is the figure. Two indifferent curves, this is IC2, this is IC1. They're cutting each other at point A. This is what has been shown here. So basically, by definition, all the combinations on this indifference curve yield equal level of satisfaction. That is as per the difference curve that we have. Hence, point C and point A yield equal satisfaction to the consumers basically, as both level are located on IC2. So if we have to discuss this further, then C refers to the point, that is C. This point will also lead equal satisfaction, and A will also lead equal satisfaction to all the consumers, or rather all the combinations on IC curve 2, because they are located on the same IC curve here. This is what they've discussed. Now, when we speak about further part, similar to the combinations, B and A will yield similar level of satisfaction on IC1. That is also discussed. Let us figure out what exactly it means. So B and A will yield similar level of satisfaction for IC1, or rather IC1 combination of products or goods and services. But now, in both these cases, this point is very common for both these curves. What needs to be done of this? Let's figure out. Now, if A is very common here, if C combination is equal to combination A in terms of level of satisfaction, and combination of B is equal to combination of A, then combination of A would be equivalent to both in terms of satisfaction. How exactly? Let us figure out. If A is equal to B and if C is equal to A, that means here A and A is common, so we can assume B is equal to C. B is also equal to C. So whatever satisfaction B will be given, same satisfaction will be derived from C here. That is what we have assumed. Now, let us go on to the next part. This violates the basic principles of indifference curve. It cannot be the point. If two different indifferent curves are there, so the point on one difference curve and the point on the other different curve cannot absolutely yield equal level of satisfaction. It completely makes the law of indifferent curve as absurd law. Since the combination C contains more of commodity Y and commodity X than combination of B, let's go and figure it out how exactly it is. Since C gives more of commodity Y and less of X, whereas B gives less of X here. See, if you can see, C has more of X, B has less of X. Similarly, B has less of Y. How can they give same level of combinations, or other same level of satisfaction? Here is what the question is. Being a rational consumer, he will prefer combination C to B, as the combination C will give more satisfaction. B is a little lower, C is a higher, hence he will take the higher combination itself. But the intersection of two indifference curve lead us to the abrupt conclusion of A being equal to B in terms of level of satisfaction. It gives you an abrupt conclusion, right? That A is a common point which is equivalent to B and which is equivalent to C as well. So people would choose A here. Thus, it is clear that the indifferent curve cannot cut each other. This proves that the indifference curve can never cut each other. Either they can be like this, either they can be like this, but they will never cut each other. So, this is the curve that we have discussed. The things that we have understood about the indifference curve is that they will never cut each other, and how we have proved it is what we have discussed here. So, this is all that we have when it comes to the properties of indifference curve here. That's it. Thank you.